Alright, so next what we're going to be doing is talking about actually testing a hypothesis in 4 steps. So we talked about some of these steps earlier, but let's talk about them in a little bit more detail. So the first thing you want to do is state your hypothesis about the population, right? So your null hypothesis is always that the population has remained unchanged, and then you have your experimental or your alternative hypothesis, where you think the population is not the same, greater than, or less than what it used to be. After that, you're going to prepare. So that's when you get ready to test. So you're going to state your significance level first, then choose the test statistic appropriate for your hypothesis. In our case, that's going to be the z-test statistic, since that's the only one we have so far. Then you're going to state and check the conditions required for future computations and state any assumptions that are being made. So this step, when we are checking the requirements, that's checking the central limit theorem. Okay, so that means that you have at least 10 successes and 10 failures, that your sample size is large enough, and that your population is large enough, and that it was random. Okay, after that, you're going to compute your test statistic and compare it to the null hypothesis, and then find the p-value. Then you are going to interpret. So do you reject or fail to reject your null hypothesis? And what does this mean in the context of the data? So the second step is we're going to choose the significance level. So remember, the significance level we denote by alpha, and we typically set that to 5%. So there's a 5% chance that we make an error. So we say alpha equals 0.05, or that's the same thing as saying 5%. Remember, we can set it to 10% or 1% depending on the situation. Okay? So if we find that the probability of p-value, which is that we make a mistake in rejecting the null hypothesis, is less than our set goal, which is the significance level, then we can reject the null hypothesis. So here's what that means. So let's look at an example. A person stands trial for murder. We set alpha equal to 0.05 and find that there is evidence that suggests that the p-value is 0.03. So first, let's write and state our null hypothesis in both shorthand and full sentences. So our null hypothesis, okay, in shorthand, is going to be that the probability that they are guilty, okay? Or wait, sorry. So our null hypothesis is that they are not guilty. So our null hypothesis is that they are not guilty. Okay? Our alternative hypothesis is that we do find them guilty. So let's write an interpretation of the significance level. So we want a 5% or less chance of saying a person is. Okay, so let's think about this. We want a 5% or less chance of saying that a person is. So remember, the significance level is that we reject the null hypothesis when it's actually true. So we want there to be a 5% or less chance of saying a person is guilty when they actually aren't. Now, if we write an interpretation of the p-value, our p-value was 3%, so there is a 3% chance the person is not guilty. So let's think about this. We wanted to set this experiment up so that there was only a 5% chance or less that we mistakenly say that a person is guilty when they actually aren't. Now, here's the deal, is that there's only a 5% chance that this person is not guilty. So, what this means is that we wanted the probability to be 5% or less that we do this, and the probability that we found was 3%. What that means is that that's low enough that we feel comfortable saying that the person is guilty. Okay, so as a summary, how do we relate alpha and the p-value? Well, if your alpha is greater than your p-value, then that means that we have a low enough probability of making a mistake to reject H0 that we feel pretty good about doing it. And there's a fun little rhyme to this. If P is low, reject HO. On the other side, if alpha is less than our p-value, so if we have a high p-value, that means the probability we make a mistake is greater than what we're comfortable with. So that means that we fail to reject. All right, so continuing on with step 2, for the test statistic, we're going to be using the z-test statistic. Okay, that's the one that looks like the z-score. We're going to be talking about other ones in chapter 9. So the key thing is that we want the sampling distribution for a test statistic to be approximately normal. So that way we can say, hey, these things are going to be outside of the empirical rule, and then we can reject H0. So these are steps that you've seen before, which is that you have a random sample, large population, large sample. The other thing is that you want independence, which means you want each observation or measurement to not influence the other one. Okay? The good thing is that usually if our sample is random enough, then we're usually guaranteed independence. So something that would mess this up would be if you had people taking a survey in front of each other and they could see each other's answers. Maybe they're not going to answer as unbiasedly as they would otherwise. So let's take a look at the next example. So recall that the fish market from 7.4, we were interested in the freshwater fish population of the United States, and we randomly sampled 250. Biologists believe that about 20% of the freshwater fish population contained high levels of mercury. So our null hypothesis is that the percentage of fish has remained unchanged. Let's see what our alternative hypothesis was. So let's say that we think that the population has increased in high levels of mercury due to pollution or something, then we would say that P was greater than 0.20. Okay. All right, so along with this, we also need to choose a sig level before we do anything else. So our sig level, let's just say, is 0.05. All right. Now, step 3 says that if our p-value is less than our alpha, then we reject our null hypothesis. So remember, if p is low, reject HO. So, for example, if we spun a coin, our null hypothesis would be that H0 is p equals 0.5. The probability that we spin a fair coin 20 times and 20 times it comes up heads has a very low p-value, meaning it's highly improbable, and thus we reject H0, which means that we have evidence coin is unfair. Okay. Now, how exactly do we find the probability of that happening? Well, what we're going to be doing is using z-test statistics and the normal distribution. So the way the normal distribution works here is we assume that H0 is true, which means that most of our samples would return p-values or values close to the population, okay? And then some samples might be less than that, okay? Now, here's the deal, is where do we look? Well, it depends on what our alternative hypothesis is. So, for example, if our alternative hypothesis is that p just does not equal 0.5, Well, it's equally unlikely on a fair coin, remember we're assuming that the coin is fair, that we would get a lot of heads or not many heads at all. So those are both equal. So there's going to be 3 different ways of finding the p-value depending on the alternative hypothesis. So if we look at a normal distribution and we have an observed test statistic of z equals 1.56, here's how we're going to find those different p-values using that test statistic. All right, so for this very first one, okay, our null hypothesis is that p does not equal p naught. So remember, if we assume that our null hypothesis is true, then getting a small amount of heads is just as extreme as getting a large amount of heads. So here's how you're going to find this, is that you're going to take the negative of your z-score, which in our case would be negative 1.56. Then you're going to find the p-value on your z-table. So if we go back and we look at our z-score table, okay, and we find negative 1.56, we're going to get 0.0594. But remember, that's only on this side. We want to do both sides. So when we do it on both sides, what we have to do is that we have to add that together. So we're going to multiply that by 2, and we're going to get a p-value of 0.1188. So this would be our p-value. Now, if our alternative hypothesis was that p would be less than p naught, then what you're going to do is that you're just going to take your z-score straight up, which in our case was 1.56. We don't have to make any alterations to it. Then what we need to do is that we need to find p on the z-score table. Okay, so if we find p on the z-score table, remember that's positive 1.56. All right, so just a reminder, on the last one, you're going to take the negative z-score. So if it's positive, make it negative. If it's negative, leave it alone. Find the p-value, and then multiply it by 2. On this one, you're just going to use the same z-score, find it on your z-table, and then that's going to be your p-value. Now, on the next one, we're going to do the same thing, so leave z alone. So leave z alone on the next one. Find the p-value. But this time, since we're finding the probability and it's on the right-hand side, what you need to do with your p-value is you have to do 1 minus the value that you found on your z-table. So that is going to give us 0.0594 for our p-value. All right, so just a summary. If you're finding a two-tailed hypothesis, which means that p is not equal to, then you're going to take the negative z-table score. Okay, so remember, if it's negative, leave it negative. If it's positive, make it negative. Find that p-value, and then since you're looking at both tails on here, you have to multiply that value by 2. On the next one, okay, you just find the z-table, you find the z-score, find p on the z-table, and then that's going to be your p-value. Now, on the very last one, since we want to look at extremes of p being greater than p naught, we're going to be looking at the right-hand side, so you're going to use the same z-score that you found before. Then you're going to do 1 minus the p-value that you found on the table. All right, so let's look at a couple examples of this. So first, we spun the coin 20 times and saw 7 heads. Okay, this leads to p hat equaling 0.35, which leads to a z-score of negative 1.34. Okay, so what we want to do is sketch a graph representing the area under n0, 1 that we're interested in. So this is 0. All right, our z-score is going to be negative 1.34, so that would be somewhere around here. Okay, but remember, this says that p is not equal to it, so we're looking for an extreme, like spinning a coin and getting 7 heads, or something that's equally as likely is spinning a coin that's fair and getting 7 tails. Right here. So remember, 7 heads is just as likely as 7 tails, which would be 13 heads. So what we need to do is find this area here. Okay, so when we do that, we need to find the p-value and write a full sentence interpretation rating the p-value to the null hypothesis. So our z-score is negative 1.34. So since z equals negative 1.34, we're going to look that up on our z-score table. So that's going to give us 0.0749, but remember, that's just the area on this side. We also have to add the area on this side, and since it's symmetric, it's going to be the same amount of area. Like if you fold in half, it would land on itself. So we need to multiply that by 2, and here's what we're going to get, 0.1498. So our p-value equals 0.1498. So the way that we would write an interpretation of this, given the null hypothesis, is there is a 14.98% chance H0 is true, given what we saw. So if we set our significance level at the beginning to 0.05, then do we reject or fail to reject H0? Well, remember, alpha equals 0.05. The question is that greater than or less than our p-value, which is 0.1498. So the p-value is actually greater. So remember, if p is low, reject H low. In this case, p is high, so we have to fail to reject. That means that we did not find evidence of an unfair coin. Alright, we're going to stop there, and then on the next video I'm going to show you guys how to do this in StatCrunch, and we're just going to continue to do some examples.